All right, in this video we're going to talk about the mole again. Now the mole is something we've actually talked about in chemistry already, but we're going to come back because we're going to start using the mole. First, the thing I want you to remember is that a mole is a quantity. Now, as I go through these notes, you'll want to make sure that you write down everything that I do and write down every calculation. These are your official notes to review you over the mole. A mole is a quantity. Now, we struggle with a mole because a mole is not a unit we've ever used or measured things in. We're used to using things like dozen and units like that are quantities that we use every day. If you were talking about, cups, as in you're going to bake something, or teaspoons, those are very obvious to us, but those quantities aren't large enough. If we wanted to deal with multiple dozens, that's great. The problem with chemistry is we're dealing with atoms and molecules. And since we're dealing with atoms and molecules, units like dozen and cups don't work because the quantity is too small. The atom itself is so small that these units, even if you had a dozen atoms of gold, for example, you can't even see it. So they had to come up with another unit to use, and it's called a mole. Now, a mole is defined as this quantity, 6.02 times 10 to the 23rd. This is actually what is called Avogadro's number. He is the gentleman that came up with this value. Amadeo Avogadro was his name, and he came up with this value. Now, there is a reason why it is this number, and I'm not really worried about you knowing that. I just want you to be able to use it. Now, for most of us, if I told you we had 1 dozen of something, we have 12, and we really don't question why it's 12. We've just known that our whole life. So really, what I'm wanting to work us toward is this idea that whenever we hear the word mole, we know it is that quantity, and we just basically deal with it. So a mole of any object is going to be in chemistry, that many atoms or that many molecules. Basically, the difference between the word atom and molecule is that atom is a single and that a molecule is a group. And that's the only difference between them. And so basically a mole is a quantity. So let's do an example and remember how to use our calculator with it. Let's say that we had 2.1 moles of, we'll just say gold. And I want to know how many atoms that is. Now, the reason I use the word atom is that gold is a single. And so what I'm going to do is I'm going to set up a railroad track using this value. Now, reminder, because it's been a while since we've done railroad tracks, we want this word to cancel, so we want the word mole to be there, and so we want to convert it into atoms here. Now, a special hint, anytime you have the word mole in a railroad track, it's always going to be a 1. It's going to come from right there. 1 mole is 6.02 times 10 to the 23rd, and I didn't give myself a whole lot of room, so I have to sort of cram it in there. The word mole is gone, and so I can actually calculate how many atoms of gold that is. So all I have to do is use my handy-dandy calculator. Now what I'm going to do is I'm going to show you 2 ways to do it if you have a calculator like this. You're going to use the EE key. This is a reminder. We've done it many times. The EE key on this calculator is right here. So if I want to put this number in my calculator, I clear my calculator, 6.02 EE23. And I'm ready to do any math needed with it. Now, if you don't have that kind of calculator, let's say you have a graphing calculator, here's how this one works. You're going to use the same key, except it's not on the key, it is actually above the key, right there. So you put 6.02, second key, EE, it prints an E, and then the 23rd power. And so you can see that it's on the screen, ready to be used. So if I want to use this calculator and calculate this question right here, so what I'm going to do, clear my calculator, it's 2.1. It's on the top. This is a big division line. Remember, this is division line. So top times top, so it's 2.1 times 6.02 EE23 equals, and my calculator says 1.2642 times 10 to the 24th. Now you'll notice as I read that, EE, it's supposed to be written times 10 to the 24th. So my calculator says E, but I have to be a little bit smarter and know that the E means times 10 to the 24th. Now, just a reminder, whenever we do calculations so that we all get the same answer, we always do Sig Figs just to make sure everybody gets the same answer. Pretty simple to do. That has 2 Sig Figs, and this has 3 Sig Figs. And typically, since this number is always going to be the same, it'll never change, we're going to base our Sig Figs on the number that could change. That has 2 Sig Figs, so my answer is going to have 2 Sig Figs. So I'm going to go 1.2 and stop, and the 6 makes it round, so my answer correctly written is 1.3 times 10 to the 24th. And that's my answer for the number of atoms. All right, let's try another one real quick. Erase this. Now that you have that, I don't have to put that in there again. Let's try another one real quick. Let's say that we have 4.63 times 10 to the 24th molecules of water. And we need to know how many moles that is. Okay, so we're sort of doing the reverse, and it's hard to read the word mole right there, so let me move that word. I want to change it to moles. See if that's a little bit better. Yeah, there's a question mark there at the end of that. All right, so here's how we work the problem. We start with the number we're given, 4.63 times 10 to the 24th molecules. Railroad track. Now, I know it's molecules of water, so I'll go ahead and add that there. When I set up my railroad track, I want this word to disappear, so I want the word molecule to be here, molecules of water, and I can convert that into moles. Now, if you remember what I said a while ago, the word molecules are going to disappear, and anytime we have the word moles, it's always going to be a 1. Always. And the number that's going to be with molecules is 6.0 times 10 to the, 6.02 times 10 to the 23rd power, as I fit that in there. So it becomes all calculator work. So this time I'll just show it on the other calculator, just for those who might have a calculator like this. All right, so I'm going to use this one. Still going to use that EE key. Now, as I look at this problem, if this is a big division sign, I always do top divided by bottom. My answer is going to be in moles because it's the only word that's not marked out. So I know my answer is going to be in moles. All right, so I'm going to do my work, and it's going to be 4.63 EE24. There it is in my calculator. Divided by 6.02 EE23. And my calculator says 7.691029. Now let's check our Sig Figs. It's going to be based on this number right here because it's the one that changes. This one never changes as Avogadro's number. So this has 1, 2, 3 Sig Figs. So I'm going to put 3 in my answer. 7.69 and stop. The 1 doesn't make it round. 7.69 moles. And there's my answer. Whenever you go to use moles and conversion with moles, it's pretty simple to do. You're going to use Avogadro's number every single